Good morning, good afternoon, good afternoon.
Good afternoon, sir.
So you have got your physics lab now?
Good afternoon, sir.
Yes,
Hello?
yes,
Yes, yes.
sir.
Okay, okay. 45.
Sir,
Yes, okay. So advance happy new year to all of you.
thank you,
Thank you,
sir,
sir.
in advance.
Thank you, sir.
Thank you, sir. Thank you, sir. Advance holiday also.
Thank you, thank you. So just wait 4 to 5 minutes to join all your
Sir,
friends. Start. Okay.
sir, not many people will join today because of last year of the day.
Okay,
Tomorrow will be a holiday.
yes. We'll do the experiment, but let's wait for few minutes. Okay?
Sir, tomorrow will be a holiday.
No, no, not a holiday. No.
Why? The first day of the new year.
Let's start.
Hmm.
Hello, let's start.
Sir,
Yes.
Sir, in the last experiment, I'm not
What's your problem?
able to.
What's your
So we are
problem?
not
Here,
able to draw the graph properly.
how to?
Sir, in the last experiment, I was
Yes.
not able to draw the graph.
Which
It's very
graph?
complicated. That's
Which
the
graph?
potential energy and energy and time graph of the pendulum, oscillating pendulum.
Not oscillating pendulum. You have done that conservation of mechanical energy.
Yes, sir, that only.
Yes,
So
sir. The graph is complicated to draw.
you listen
you
what I'm
can.
telling you. Listening, sir.
Yes.
You have to
तो
take the
एक्सेल शीट में भी नहीं बन रहा है, एक्सेल शीट में भी ट्राई कर लिया फिर भी नहीं हो रहा है.
you listen what I'm telling you.
ओके.
First of all, you have to take time in the x-axis. What is the maximum time? What is the minimum one? It is I already told you. You have written the observation or no?
Yes, sir.
What is the time period? You tell me. Yes, you tell me.
Sir, something like 0.35 second.
What?
0.35 second.
0.35 second? No. How did 0.35 second? You don't know. That is not the time. That is position, I think.
So 0.54.
0.54. Yes, 0.54. And the maximum is
1.31.
1.31. Then we start the scale in x-axis. In x-axis, what we will do? You take the interval of 0.05 second. Okay. At origin, you start x-axis, that is 0.5, then 0.55, then 0.6, 0.65, then 1.3, 1.35 at the end. Got it?
Yes, sir.
And in your y-axis, you know how to take energy? In y-axis, it starts from 0. 0, then 0.001, 0.002, 0.003, up to the maximum energy that you have got in that experiment.
Sir, we did it like that, but still it is not
Listen,
coming.
first listen me.
Yes, sir.
After that, what we will do? You first show the 13 points between time and kinetic energy.
Okay, sir.
After showing those points, you plot the sinusoidal curve like this. It is not necessary that all the points will come on the graph. Got it?
Sir, not a single point is coming in
What?
the graph. Not a single point is coming in the graph.
How? You are not able to show the points on the graph.
Sir, many students have tried. No one is able to get it.
You talk about yourself.
Yes, sir. I am also not able to do
Whether
it.
you are able to show those points on the graph or not,
No, sir. I am not able to. So,
then it is not possible to plot the graph. If you can't show how to, if you don't know how to show a point on the graph, then it is not possible for you to plot the graph.
sir, I know how to plot, but when I am plotting the points, it is not coming like a sinusoidal. It is
Yes,
coming something
I
else.
you listen, first you have to show the 13 points between time and kinetic energy.
Yes, sir.
I have already told you, it is not necessary that all the points will come on the graph. You take the maximum points and plot the sinusoidal curve. Okay, if all the points are not coming on the graph, that's okay. Take the maximum point and plot the graph. Clear?
Okay, sir. Okay,
Got
sir.
it now?
Okay, sir.
Then you jump to the time versus potential energy. Again, show the 13 points. After showing the 13 points, plot the sinusoidal curve that will start from the minimum to the maximum, then maximum, then minimum. Then you show the 13 points between time and total energy. Take the maximum points and with the help of the scale, plot the straight line. Okay.
Okay, sir.
Today we are going to do another experiment. That is a
सर
medium.
लैब मैनुअल कब तक मिल जाएगा?
What?
लैब मैनुअल?
Lab manual.
यस.
I don't know. You talk to your teacher. Who will take your theory class.
ओके.
He'll send you or somewhere you got. He'll tell you.
हमने हमारे मतलब वो थ्योरी के सर को पूछा था सर, इनके शर्मा सर को, लेकिन उन्होंने बोला कि लैब में तो कुछ बोला नहीं गया है, इसलिए अभी तक नहीं मिला है. जब बोलेंगे लैब में तभी मिलेगा.
Then you have to wait. Okay.
अच्छा.
Then you have to wait. No more talking. After that, you have to wait. Today's experiment is you have to verify Newton's second law of motion. Can anybody say what is Newton's first law?
An object in rest will remain in rest, and object in constant motion will remain in constant motion.
Until and unless an external force is applied.
Unless and until an external force is applied on it. Then what you can derive from the Newton's first law, or what you can get?
Inertia.
Inertia.
Inertia of rest and inertia of motion. Then what is Newton's second law?
F is equal to ma.
F is equal to ma. That is Newton's second law. Define Newton's second law. Can you define? Anybody else?
So force is the rate of change of momentum.
Force is the rate of change of momentum. This is Newton's second law. Anybody else?
So the acceleration of the object is directly related to the net force and inversely proportional to the mass.
Force is directly proportional to the rate of change of momentum, and it takes in the direction of the object. From there, for a constant mass, you can derive F is equal to ma. Yes, using this formula F is equal to ma, we are going to verify Newton's second law. So first of all, for this you need another kind of sensor. Last class I have shown you the motion detector. In the first class you have seen dual length force sensor. Today I am going to show another kind of sensor, that is accelerometer, low G accelerometer, that only detects the acceleration of that object when you apply force on a particular object. Okay? You see here, this is your cart, this is your dual length force sensor, this is your accelerometer, low G accelerometer is written here. Okay, if we move this vertically like this, when we apply force on this subject vertically like this acceleration can be detected by this accelerometer. We apply acceleration right horizontally, and this acceleration can't be detected by this accelerometer. Okay, that's why you have to apply force on this subject vertically over it. Got it? So before going to the experimental part, you please, I'm showing the screen, you please write down aim of the experiment, materials required, theory and tabulation. Then we'll do that experiment. Okay? Right here, the aim of the experiment. This is the aim of the experiment, materials required, theory or working formula, then observation table, then calculation or have to calculate, percentage of the conclusion. You first try it up to this, and materials required, working formula, then observation table. You write this in your rough copy. You all have rough copy with you?
So in rough practical copy,
Yes, sir.
or normal rough copy?
You write in a rough copy.
Yes, sir.
From the beginning, I told you you have to make a rough record and a fair record. And you are asking now in which copy you have to write. It's not good at all. Write aim of the experiment, method.
Sir, experiment name.
Sir, not audible.
Sir, video froze.
अरे भाई एक्सपेरिमेंट का नाम क्या है?
Aim of the experiment to verify Newton's second law of motion.
Name of the experiment.
What?
Name of the experiment, sir.
Newton's second law. Newton's second law.
Sir, can you scroll down?
Yes. You all have written?
No, sir.
Yes, sir.
Plot this table for 10 readings.
Sir, scroll little up.
Okay.
Sir, scroll up. Scroll. Sir.
Someone saying down, someone not. Listen to me. Okay.
So that observation table.
Okay. Plot this for time reading.
Sir, done.
Done. Then I done the calculation part. Average F by A when force is applied on the card, usually mass of the card M. Average F by A for the card with the dead mass, the mass of the card with the dead mass into the nominal mass added on the card into minus M adding this thing.
ସାଟିକୁ ଉପରକୁ କରନ୍ତୁ।
What have to make it up?
Sir, done.
Done.
Yes, sir.
Then you write.
No, sir.
What?
Was not done.
No, sir.
Excuse me, sir.
Okay.
Excuse me, sir.
Yes.
Sir, do you have the lab manual with you?
No, I have no manual with me.
Oh, okay, sir.
That's why I made this my own and evaluate this. For this experiment only I made this.
Yes, sir.
Sir, completed, sir.
Completed.
Yes, sir.
This part, error and conclusion.
Yes, sir. Error and conclusion also completed.
Okay, very good. Now you
Wait.
yes, not written. Sir. Completed? Completed?
Yes, sir.
Okay, then you go to the experimental part, okay? You see, I've already told you this one, see, this is the card, you don't know what is the mass of this card, you are going to find out the mass of this card using this force sensor, which measures the force that acted on this card, this is the acceleration that developed after applying force on the card. Everything you can get for a specific period of time. And from there, using that formula, F is equal to ma or m is equal to f by a, you can find out the mass of this current. Got it? Yes or no? Respond yes or no. That is your mass m1. After that, you don't know what is the mass of the objects also. Then what you have to do? You have to add this here. You have to add this, and by similar process, you are going to apply force here that can develop the acceleration, and from there you can measure the force and acceleration for a specific period of time, and from there you can find out the mass of this card with this unknown object. That it will be your mass m2. Okay. And if you subtract m1 from m2, you can get the mass of this object. After that, you can calculate the percentage of error. I can give you the standard mass of this object. Got it? Yes or no?
Sir, can you repeat it?
First of all, you have to run the program and apply force on this card vertically like this, where you can get the time and acceleration graph and time and force graph. Okay. From the time and acceleration graph, we have exported the data to the Excel sheet just like the previous experiment. And from there, for a specific period of time, we can calculate the mass because the mass of the card is a mean constant. From there, you have to take 10 readings and you have to take the average mass. That is the mass m1. Got it?
Yes, sir.
After that, I will add this mass to this card. I can show you at the time while I will add. I will add here and repeat that process. Again, I have to apply force on this card running the program. Again, you have to measure the time and acceleration graph and time and force graph. You can detect that in the program. From there, you can calculate the mass of this card with this unknown object. That will be their mass on 2. Got it?
Yes, sir.
Yes, sir.
From this M2, you subtract M1. Then you can get this mass of this object or not, tell me.
Yes.
After that, you can plot two graphs. One graph is for M1, acceleration versus force. The other is graph for M2, that is acceleration versus force. And from that graph, you have to find out the slope. And from that slope, you have to calculate that again. And you have to verify that standard mass also. Clear? Yes or no?
So your voice is a bit breaking.
You have to plot the graph between acceleration and time. For M1
Okay, sir.
as well as for M2. From there you can calculate the slope. From the slope also you can calculate the unknown mass of this object. Got it? Yes or no?
Yes, sir.
Yes, sir.
Okay. Now I am going to the program. I am minimizing this and going to the program. You know? This is your program. Okay, you see, when I have already told you, again you just see. When I will run the left-handed program there, when you run the program and apply force like this vertically on it, you can get the which curve you see here on the program. You can see time acceleration graph and time force graph. If we select your acceleration, you can get the jump graph of time acceleration. If we select here, you can get the jump graph of time force. Got it? Yes or no?
Yes, sir.
Okay. Now you see, I've already told you. Now I am going to apply the force here. Sir, it helpful. Then you can get these two running graph. One is time acceleration, other is time force. After coherent around coherent is respond it has stopped data collection. Okay, start making. Okay. Wait. Now I am applying force. You see, are you getting the curve? Time and acceleration, time and force. Are you getting it now? Now I am applying force and theta. After applying force like this for 10 to 15 seconds, you have to stop the program. Stop. Okay, then you see here, this is the jump graph of this one, time and force. If I will click here, you can get the jump graph of this one, time and acceleration. Okay, after this, I will choose a specific portion of the graph and export that to the Excel sheet. Let I want to choose from 1 to 10. Then I will export the data to the Excel sheet. Right click, export to Excel. Got it? Yes or no?
Yes, sir.
Then again you have to open the force graph and select the same time period that you have chosen in time and acceleration graph. 1 and 10. Now I will export the data to Excel sheet. The similar process. Right click, export Excel. Now you can get here. Now I am copying this from this page. And I will paste this in the next one. Okay, now you see here, we have got two time columns. Both the time columns are same, you see, 1.0314, 1.0314. Both the time columns are same. Yes or no?
Yes, sir.
I mean, I have copied the data properly. Then I will delete this column. What do you get here now? Time, acceleration, force. Now, according to the table, you write, this is time in second. Just wait, I'm making this. Time in second. This is your acceleration in meter per second square. Then your force in Newton. Okay, after this, you have to calculate here the mass. How to calculate this mass? I have already told you. How to calculate the mass? You can get the force and acceleration.
By acceleration.
F by
F by. You see, for a specific period of time, we can calculate the mass. by using that formula F by. This is your force divided by this is your mass. Enter, and if you drag this here, then you can get all the data set fill up here. Okay. After that, first you have to find out the mean of this. Let I am calculating the mean of this. Accordingly, you have to take the readings. Okay. Auto sum average. I got the average here 0.668. Okay. Now I am selecting some readings. The readings you have to note down. You have to find the average. Are you clear?
So the readings you are choosing here, that is random.
What?
The readings you are choosing here, that is random, or it is specific.
Random choices so that you can get that average mass in between 0.65 something. I have shown that one. Now, if got the average here, auto sum average. This is the average. That is your M1. Average mass. You write down this table in your first table. This is the M1.
Sir, once more, can you explain how to find that average?
What?
How to find that average mass?
Okay, select all this, all that, sorry, select all the 10, okay, your auto sum, then average. Got it? Yes, yes or no?
Yes, sir.
Please write down this table, complete table in a rough copy. You have plotted the table, yes or no? You have plotted the
Yes,
table
sir.
or not?
Yes,
Yes,
sir.
sir. Yes, sir. Yes, sir. Sir, show the readings.
Completed?
No, sir. Please wait.
No, sir. No, sir.
Okay, please write. Write, I am giving you 10 minutes. Okay? 10 minutes or 5 minutes. Within 5 minutes, you write. Then I will tell you how to plot the graph, how to do the calculations. There are so many things here. You go to the another part also. This is one of the part of this experiment, then you go to the other part. Completed?
Yes, sir.
Yes, sir.
Yes or no? Written?
Yes, sir.
Yes,
Okay.
sir.
You should please respond, then we'll go to the next part. No? Then you see, you go to the next part. Then, I have already told you that is the one part of the experiment. Another part you see, this is the unknown mass. You don't know what is the mass of the subject. Okay. Now I am going to add this mass on your cart. Then you repeat that process again. So just wait, you see, I will show you how I am adding this mass. Okay, just wait. I have replaced the accelerometer from that card. You see, I am going to insert this here. Okay. After that, I will add this mass. If you will be in the lab, you have to do this work by yourself. Okay. After that, you have to keep this here. And tight this. You make this vertical. Only the vertical acceleration can be detected by this low G accelerometer. It is low G accelerometer. Okay, attend this. Now you see, can you see this? This mass is added. This is the unknown mass. We have got the mass of this card with this force sensor. It is 0.654 kg. Now I have added this unknown mass on this card. Then you have to repeat that process. Which process? You have to apply force here. Again measure that acceleration and time and acceleration and force graph. From there you have to export the data to the Excel sheet, and from the Excel sheet you have to put on again return ratings. Got it? Yes or no?
Yes, sir.
Yes, sir.
Now I am going to the program again. Sir, because you see time versus acceleration graph, time versus force graph. I'm applying force here. The similar process just I've shown you. After running this for 10 to 15 seconds, you have to stop the program. After that, that's over your experimental part. Then, if you go again, if you choose a smaller portion of the graph, let's choose this one, then export this Excel. The similar process, force one, then export this to Excel. You have got again two Excel sheet. If you open this time and force, we'll copy this, the similar process, then paste that on the previous one. The similar process you can get here. The time, acceleration, time, force. You see both the time columns are same. Isn't it or not?
Yes, sir.
Then I will delete this column. Then what do you get here? Time in second. A similar process. Just to wait. Time in second. Here you can get what? Acceleration in meter per second square. Then here you can get force in Newton. Then by similar process, you are going to calculate the mass. I have already told you how to calculate the mass.
Force by acceleration.
Force by acceleration. For that, you have to apply that formula. Equal sign. This is your force divided by this is your acceleration. Then enter. If you drag this from here, you can get the mass. Okay. After that, first we check what is the average mass. You see, I am selecting from here to the last one. Okay. Then auto sum average. It is written there. The average is 1.22. Okay. Similarly, I will choose some readings from here. 1.22 or like that. I have taken different readings. Then I will delete the other parts just like the previous one. Then you see this is a time, acceleration, force, mass. Then again I am finding the average here, auto sum average. We have got your 1.190. This is your average mass M2. We write down this in the rough copy. Okay. Are you writing?
Yes, sir.
Yes, sir.
Then I will fill the graph part. Are you writing? Hello, you're writing or not?
Yes, sir.
Yes, sir.
Yes, sir.
When you get completed, tell me, okay?
हो काय म्हणला नाही नाही
Hello, students.
Yes, sir.
Yes, sir.
Reading. Right, done this. Completed.
Yes, sir.
Okay. Then it is in properly to me what I am telling you. We are going to plot the graph now. First of all, to plot the graph between acceleration and force. Okay, for M1. If you take this acceleration in the x-axis and this force in the y-axis to plot that graph. I'm going to plot this one, okay? There will be a straight line. Y is equal to mx plus c, just like the first graph. Here, insert, scatter, this. Can you see? Then you have to click on at any point, right click, add trend line, linear, display equation, close. See here, you see here, this is your equation. Okay, here y is equal to mx plus c. You can see what is your slope here? What is your slope here?
Mass.
0.67.
0.672. Here you have got 0. The average is 0.654. Okay, 0.654 kg. But here you have got 0.672. Okay. The next part you see here, this one. Again, I am now copying this acceleration and force. Then again, if you plot this graph, this is for M2, this is for M1. Okay, this is for M2. M2, but we have got 1.190. Insert, scatter the first one. You can see this. Then here, a trend line, linear, display equation on chart close. Here you can get 0.931. And the difference between these two, this is your M2. M2, here M2, here you can get M1. The difference between these two, you can get the unknown mass of that object. But exactly what is the unknown mass of that object? You can find here 1.190, 1.190 minus 0.654. (0.536 kg). But here you are getting, this is less. Okay, you see. देखो, select, insert, scatter, and this. Right click, a trend line, linear, display equation on chart, close, you can get this. Okay, we are getting 2 points, that's why we are getting this type of slopes. Okay, then how to plot this graph? You see, listen me properly. Hello, you have no data with you? Yes or no?
Yes, sir.
Yes, sir.
Now you have,
Yes,
to
sir.
plot, you have to plot the graph between acceleration and force for M1. From there you can get the slope, that will be slope M1. And for the second part, again you plot the graph between acceleration or force for M2 and take the slope, you can get there from M2 and find M2 minus M1, that is your unknown mass. Got it? Yes or no? In your calculation, you see, I have already shown that one in the calculation, you see, it is here, average F by A when force is applied on the car, that is mass of the car M1. You have to write down here 0.654 kg. Do you listen me?
Yes, sir.
Right here 0.654 kg. Again, average F by A for the car added with mass, that is mass of the car plus added mass, M2, 1.190 kg. Then you find M2 minus M1, 1.190 minus 0.654, that is 0.536 kg. Okay?
Yes, sir.
Then go to the next part, you see. Here standard mass of the unknown object, you write here 0.5 kg.
Yes, sir.
Then you write observation mass, observed mass of the object. Observed mass means that you have got 0.536 kg. Are you writing?
Yes, sir.
Then you have to find error. Standard means 0.5 minus 0.536 divided by 0.5. Take the modulus into 100. Then you can get the percentage of error for this experiment. Okay, after that you see, next part you see, ratio of the force applied on a given object to its acceleration F by A is found to be constant, which is verified with the second law of motion. Using this relation, the unknown mass added to the card is found to be how much kg? 0.536 kg with an error of this percent. Got it or not?
Sir, what is the standard mass of the unknown object?
Yes, sir. Repeat that again.
Well, I have come to the conclusion, but you are saying that you are not using that part. Please be clear at the time what I am explaining. If you are not able to understand or not able to listen me, you said at that time, standard mass of the unknown object 0.5 kg. Are you writing?
Yes, sir.
Then object mass of the object. You find it. What is the object you find here? M2 minus M1. Write down that here.
5.3.
Then find the error. Standard minus object by standard mod into 100. That will be a calculation, error calculation. Got it or not? Hello students, you are getting or not?
Yes, sir. 7.2.
What?
7.2.
7.2.
Yes, sir. Error.
You see the conclusion. If you write the added mass to the card is found to be 0.536 kg with an error of 7.2 or whatever maybe you have got. Got it? Yes or no?
Yes, sir.
Yes, sir.
Huh? Then you come to the graph. You see, I have already told you, again I am telling you, another thing we see. First of all, if you go to the plot the first graph, that is for M1. Take this acceleration in the x-axis. Write down the x-axis, how to take the x-axis. 10 small division 1 meter per second square. Got it? Yes or no?
सर
Yes.
जब हमें वो ग्राफ नोट में वो करना है तो ऐसे ही ग्राफ करने से चलेगा ना, मतलब जैसे स्ट्रेट लाइन है लेकिन कोई पॉइंट को टच नहीं कर रहा है, पॉइंट साइड में रहेगा और लाइन साइड में.
Yes. You see, I am talking about the first graph. This is the M for M1. You have to take this in your x-axis as the interval of 1 meter per second square. Right here, take here on the upper part of your graph paper. You have to do this in the hard copy, okay? Right here, 10 small division is equal to 1 meter per second square. That is in x scaling. Got it? Are you getting or not?
Yes, sir.
Yes, sir.
Then in y-axis you write in scale. You write on the most upper part. Y scale. 10 small division is equal to 1 Newton. Got it?
Yes, sir.
Yes, sir.
Then you show these 10 points and plot the straight line like this and take the slope. From that slope we can get M1. You can take the slope. Yes or no?
Yes, sir.
After that, similar process if you plot the second graph. Take this for M2. Take this in x-axis 1 meter per second square. Take this in y-axis 1 Newton. Then show these 10 points. After that, you taking the maximum points. It is taken in this manner. But if you take these points and plot the straight line, that will be, I think, better. Okay. The no points here, we will join some points in between. Then it will be better. And from there, if you take the what? Slope of this one, that will be your M2. And again, you find the difference M2 minus M1, you can get the unknown mass. Got it or not?
Yes, sir.
Now you plot this graph and show me the graph. To take the units in this manner, 0, 1, 2, 3 like that, here also. You see, we start this from 4, 4 or this from 5, 5. So this will be like this. It will be better if you plot this straight line from this to this. I think that will be better. Hello, students.
Okay, sir.
You see, if we don't take the straight line like this, if we plot this straight line here from this to this, I think it will be better for you. Your slope will be more in that cases, You can get the less here. This point and this point. Okay. That this will get an upper part, this will rise on lower part. Got it or not?
Yes, sir.
Yes, sir.
And from there I will take the slope. The slope will be more in that cases. Okay. Please plot this graph and show me the graph. See first, so plot the first graph. Okay. Plot the first one and share. I want to show. I want to see that one. After that, you go to the next one. Plot this graph first.
Sir, can I present my screen?
Hello, who want to represent?
Sorry.
You got it?
Yes, sir.
So, may I present? Can
This graph in your hard copy.
no, so Excel.
Now please plot this in hard copy. And from there you have to calculate the slope. It will be like this. You see, I have plotted one graph here. I am showing you. Okay. You see. Stop painting. Hello. Can you see the graph I plotted?
Yes, sir.
Yes, sir.
It plot graph like this. This is for M1. You see, I have written everything. Here the scale, here the slope, here how you have taken the x-axis, how you have taken the y-axis. Okay, you plot the graph like this, neat and clearly. Got it?
Sir, we have to draw graph in single paper or two paper.
Two different papers. You take two different papers. The two sheets
Sir,
of
can we
paper.
draw in single?
You see, I have drawn, I have plotted one graph in one sheet of paper. Like that, you have to take another sheet of paper and plot the next one. Do you understand what I tell me?
Yes, sir.
Okay. You see there, I am sharing that again now.
सात पड़े गए ना
What's your problem? Hello? Are you plotting the graph or not? Yes, no problem. Hello, you got select? देखिए जी सोची कर लो
Volare che accidente, non conosco, che conosco volare.
Ashish Sahu, are you present?
Sì, nessuno.
Ashutosh Ranjan,
Yes, sir, present.
Are you plotting the graph?
Yes, sir.
Bhumika Jana.
Yes, sir.
Are you plotting the graph?
Yes, sir.
Anjali Priya. Gurman Singh. Gurman Singh, are you plotting the graph? Harish Chandra.
Yes, sir.
Are you plotting the graph?
Yes, sir.
Kamal Nayan. Who are not responding will take the next sign. Kamrup Mahapatra. Kamrup. Kirti Kiran Jana.
Yes,
Sir, can
sir.
you show the Excel sheet again?
Are you plotting the graph?
Sir, can you show the Excel sheet again, please?
Which one?
Excel sheet.
Okay. Can you see now?
Yes, sir.
Just wait.
Just move a little up.
Okay.
Just a little up, sir. हाँ बस हो गया बस.
Excuse me, sir.
Yes.
I completed with my graph. Can I show you once?
Just wait. Just wait. Start observing.
Hello? What's the problem?
Yes, sir. I completed with my graph.
Can you show?
Yes, sir. 1 minute. I'm switching on my video.
And secretly that part.
So can you see?
Stop presenting. Just wait, Akash. Just
Yes,
wait, I'm
sir.
telling you. Yes, a little bit more upper button. You have written the slope, very good. Okay, then you can find out the slope. You have got the slope, what is the slope you have got?
So 0.70 something. Yeah,
Point,
7066.
0.7066. Okay. What according you have got, you have to find accordingly. Okay. According to your straight line, you have got that slope. Then you plot the next part just like I have shown.
Okay, sir.
Okay.
Yes, sir.
It's good. It's good. You go to the next graph and plot that. Akash,
Yes, sir. Yes, sir.
I am showing that one. I have shown you. You have to plot that. Is just wait. I am repeating this first. Present. Entire screen. See. Plot this graph. I told you see. You have to plot here from here to here the straight line. Okay.
Yes, sir.
Plot this. अभिषेक पटनायक, आदर्श पटेल, have you completed?
Yes, sir.
Can you show?
Wait, sir.
भूमिका जना, just wait others. They not make the scale, make the scale little bit upper to the right side. Just it is not clearly visible. No, make the inverted. I think you have written those things. Yes, yes, yes. Okay. That's okay. From there, you have to find out the what? Slope M1. What is the slope we have got? Others.
Wait, sir.
What is the slope we have got there?
So I haven't calculated it.
Not audible. You find the slope or not? Others. Others say what the slope or not?
Yes, sir. I'm calculating it.
Okay, very good. Sagar Das.
Yes, doing, sir.
Okay. Harish Chandra.
Currently drawing, sir.
Completed.
No, sir. Second one is drawing.
You saw the first one, what you have done? Let me see. Harish, you presentation. Just wait. Where is the graph? Make that upper. Make that upper. Oh, okay. It is write down here the scale. Okay, here the scale, y scale, another below of that x. You write down what you have taken in x-axis. Acceleration in meter per second square. In y-axis, if you write force in Newton. Okay, then find what is the slope we have got. This is the scale. 10 small division, 10 small division. In x-axis, 10 small division is equal to 1 meter per second square. In y-axis, 10 small division is equal to 1 Newton. Very good. After that, the lower part you see, make that upper, little bit upper. Here, in the lower part of the scale, you have to write here, just below the scale. Here, acceleration in meter per second square. Here, force in Newton. Then you have to write down here what is the slope you have got. Calculate the slope and write here. Just below that equation. Okay? Yes or no? Very good. Go to the next graph. Go ahead. Go to the next graph.
So excuse me. Hello.
Akash, you want to solve?
Yes, sir. I completed with the second graph too. If you can check it,
Please.
please.
So that
Yes, one
is there
minute.
a video?
Yes, one minute. Hmm.
Make that down. Just a time. Stop doing it. Yes. Make the video record. Please blurring with it. Make it still. Okay, it is almost. It is almost and it find the slope. Don't take from the end to the end. You take in between. Akash.
Yes. Yes, sir.
You take in
Okay.
between at the points that come on the graph or on the straight line. Any 2 points find out the slope at any 2 points. Okay.
Okay, sir.
Akash. Got it or not?
Yes. Yes, sir. So I took it in between only.
Again, again.
So I took the best fit of line in between only. Best line of it.
You can take anywhere. Just I have shown now. I have shown on that Excel sheet. You can take anywhere and from there you can calculate the slope.
Yes, I got the slope 1.0875.
Yes, then from there you can calculate the mass into minus m1.
Yes, yes, sir. Okay, sir.
36 है सर है 36 है स्टाइल में है सर संख्या सपोर्ट है 40 अच्छा तो देखिए तो थियोरी को 25 तक मोटा बड़ी में 40 किलो
Guys,
Yes, sir.
if we say you are listening, hello, you are listening, I am telling you. So this is the, I have told you how to maintain this PR record in the last class. I have given that format today also, that Word file I have given, you have written that part, aim of the experiment, methods required, working formula, observation table, calculation, percentage of error, and conclusion, you all have written those parts.
Yes, sir. We have it.
Okay, this is the way of maintaining a CR record. Another thing you will see, next class, okay, we will do the experiment within 1 hour and the next hour we will check it in everyone's graph record from experiment number 1 to 4. Accordingly, you can get the mark also. If you are not able to show, then you can get mark on that experiment. Mind it. All of you clear? And we will make a list here who are showing in the graph or not. Do you get it or not?
No one is responding.
Adas Patel,
Yes, sir.
do you listening me or not?
Yes, sir. Listening.
Please respond, yes or no. What I told you, understand or not?
Yes, sir.
If you not able to show your graph in the next class of all the 4 experiments, I have already told the first graph about that experiment sensor calibration, that is one graph. In your conservation of mechanical energy, I have to plot 2 graphs. One is time versus energy, the other is position versus energy. The third is today's experiment. One graph is between acceleration and force for M1. And the second graph is between acceleration and force for M2. All the 5 graphs you have to show in the next class. If you are unable to show, then you can get marks for that experiment. Mind it.
Okay, sir.
And you say this to your friend also. Those who are not attending today, or those who are absent today. Okay?
Yes, sir.
Akash,
Yes, sir. Okay.
you share this with your friends. They should be prepared in the next class with all the graphs for all the experiments. And in the next experiment also we have one graph. You have to plot that graph on that day. You have to show all the 2, 4, 6 graph on next class. All of you clear? Others?
Yes, sir.
Yes.
Yes, sir.
Clear? So let's start. Or any doubt? No doubt? Do you have any doubt? No doubt?
No, tomorrow is holiday.
What?
So tomorrow is holiday or not?
No, I don't know.
No holiday.
No holiday. Sir is telling no holiday. Okay.
Holiday. Every process will start, no notices come.
So all of you have a very happy and prosperous New Year. Happy New Year to all of you.
Thank you, sir. Same to you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Okay.
Happy New Year, sir.
Let's start this.